When I started to pause. Hi, everyone. Thanks for joining us. We're going to get started in a couple minutes. We're just going to let a few minutes, allow a few minutes for people to join. So just bear with us. We hope to start at 8:05, so just about 5 minutes. In the time that you're joining, feel free to take a look at the console. At the bottom, you have Q&A, and you have a chat option as well, which will enable you to communicate with the panelists as well as the attendees if you'd like. So feel free to use these and also to ask questions throughout the session. At the end of the session, they'll make time for Q&A. So feel free to use that. So just a couple more minutes, just some patience, and we're going to get started at about 8:05. Thank you.
Thank you, Sharon. So I guess we'll wait another few more minutes before we start the session today. But before we start, I would like to give my special thank you for organizing this webinar, both to Elizabeth Stilson, who's put together this webinar, I think, quite phenomenally on her 9 months of pregnancy. So this is truly amazing. So thank you so much. And thanks also, Sharon, for doing all the support and the help for putting this event together. Obviously, super happy to have you guys here on the session, and thank you for doing this amazing work.
We're always happy to have you, Arthur. One of our community favorites. So yeah, just a couple more minutes. I see folks are joining. Just a few more minutes. We're going to get started around 8:05. We'll give it a few more minutes for people to join. Yep, so just bear with us. We want to thank also the different communities that are joining us. This is a joint event hosted by a number of communities, so we hope it'll be a good one. We expect it to be a good one, Arthur.
And I guess you guys also have the chat over here to ask questions and collaborate in chat, I guess, because these sessions, you know, it's usually these webinars are going unidirectional, so it's less fun to speak to myself or to my laptop. So feel free to put together questions and ask over the Q&A session here. Throughout the talk, I guess we'll be collecting these questions and trying to answer them. And also we'll have some time towards the end to address some of the questions that you might have throughout the session. So feel free to put them in the chat box here.
Yeah, and as this is our take on a virtual meetup, the idea is to have a kind of community feel. So feel free to also interact via the chat and meet folks that are here, say hi. We do want you to at least have the opportunity to network and meet people that are like-minded. So definitely do take advantage of that. All right, folks, just another minute and we'll get started. Thanks for joining us. We really appreciate your time.
So let's enjoy the 1 minute we have here, and you guys who already connected, you can put in the chat some details about yourselves. Where are you guys from? Let's give this chat feature a try. So where you guys are from in the world? I see a lot of interesting names in the attendees list.
Boston, boom. A lot of Israel, because this is a joint event through the Cloud Native and Open Source Israel alongside the DevOps Israel community. So We see some folks from the Israel community, but it's really interesting to see folks from other communities as well. Istanbul, Spain. This is very cool. Welcome.
Cool.
South Korea. South Korean in Tel Aviv. That's even more impressive. Silicon Valley. Awesome. Cool. All right. It's just about 8:05, and I don't want to take up too much of your time. Really happy you're introducing yourselves. We have someone from Saudi Arabia, a bunch of Israelis, Spain, Turkey. Very cool. Welcome, welcome. All right. So I'll be really, really quick. Welcome to a joint event hosted by the MyDevSecOps community, but in partnership with DevOps Israel, like I said, Cloud Native and OSS Israel, alongside the Cloud Online Meetup. We're really happy to bring all you folks together for this excellent event. Just a few things on my end. So we definitely have a cadence of excellent virtual events. You know, COVID-19 kind of forced us to rethink how we do community. And we want to ensure that we keep the momentum going throughout the year. So this, alongside many other great events. So definitely check out the DevOps Israel Meetup, the Cloud Online Meetup, and the Cloud and OSS Meetup. You can join the MyDevSecOps community if that's an area that interests you at mydevsecops.io, and join our Slack to take part in the conversation. And just one of the types of things that you'll discover through this community, just this week we'll be coming out with the 2020 State of Open Source Security Report by SNCC. So I'm putting a link in the chat now. You can feel free to pre-register for that. And definitely see what's happening in the open source security space. Without further ado, I'd like to introduce my friend and a prominent figure in the community to talk about what it looks like to build a managed cloud service on Kubernetes. Sounds pretty simple to me, but I'll let you take it away. Thanks, Arthur, for joining us, founder and CEO of JovianX.
Amazing. Thank you. Thank you so much, Sharon. And thanks again for putting this event together. So, hey, everyone, and welcome to today's webinar on building managed cloud services. And we are going to look specifically on Kubernetes and how to use some of the cool stuff Kubernetes has to offer in order to help us build a managed cloud service or a SaaS product. So, you know, usually when we talk about SaaS and we talk about cloud services, you know, we go to this nice GUI, we go to this nice website, we do a simple login, and we have some magical features appearing to us. But if you've ever been involved in building one of these services, usually internally it looks like something like this, where you have this spaghetti code, various services communicating with each other, doing some weird operations in the backend. Some scale, some do not scale, and we have this very interesting coexistence of all these components working together, creating this nice little unicorn of a SaaS product. And just to show you guys that I'm not exaggerating, so this is a real-world architecture of a customer that we have. I've hidden all the proprietary components here, but like in a nutshell, we can see like a bunch of open source projects being used and a bunch of open source components being used to realize their solutions. So you have like Kafka, you have Mongo, you have Influx and Prometheus, and tons of like open source components, and also tons of services to realize the internal business logic of this cool product, right? And you have like multiple development languages, and these are not even microservices. It's not that each component is a microservice. Rather, each black box here is basically a full-blown service doing some execution, some parsing, some ETL, some rendering, filtering, basically getting data and iterating on data in order to fulfill this cool SaaS enterprise B2B product. So what is the agenda for today and what are we going to focus on? Obviously, when we talk about SaaS and cloud services, there are like tons of topics we can talk about. So let's see what we're going to focus on today. So first of all, I'm going to dive a little bit deeper on what does it mean to be a SaaS product and what SaaS actually is, because I think there's weirdly enough some confusion around that even today. And I see the word SaaS being used both in the technical context, but also in the business context. And like there's some confusion around that. So I'll dive a little bit around that. Also, then I'm going to segue to discussing architectural related stuff and how do we build a cloud native service and how do we even build a cloud service leveraging the various cool tool sets that we have out there today. This is not a technical deep dive session, rather more of a high level architectural session. I'm happy to share the technical gritty details on how to implement the various concepts I'm going to focus on today. So feel free to reach out after this session if you're like interested in the details on how to implement some parts that are in this session. Then we're gonna talk a little bit about why Kubernetes. Like, you know, we take Kubernetes for granted. I assume Kubernetes was in the title for the talk, so some of you joined just because, hey, let's join a cool webinar on Kubernetes. But let's look and you know, make this a decision, an informed, an active decision, and not just because Kubernetes is hot right now and it might change tomorrow, so we regret our decision, right? So let's, you know, see the reasons why we're even using this technology in order to build cloud services. And then I'm going to share some of the practices. Some of them are best practices. Some of them are very specific to certain use cases. So obviously there's always room for various interesting use cases, and not all practices are good for all use cases, but I'm going to focus on some of them specifically for Kubernetes for building cloud services. And again, to set the context and the mindset for the talk today, let's focus on three specific use cases that we can think of that might make sense for enterprise B2B cloud product. So there are three categories that are very popular and predominant and gaining a lot of traction in the past year. And first is cybersecurity as a service, analytics as a service, and database as a service, where we have, you know, a huge surge of consumption of these services in the past year or so. And there are obviously a lot of cool brand names that have become popular specifically for the cloud services. Other brands are trying to gain momentum using low-touch, self-serve cloud products, and of course they're right. It's just a matter of time until cloud takes the world, or cloud has taken the world, but taken a major rev share across the consumption. And to talk specifically about use cases in the context of a cyber as a service, analytics as a service, and database as a service, we're going to focus on taking open source applications and turning them into cloud services, taking on-prem software and turning that into a cloud service. But also a use case that's very relevant is the multi-service, where you have like a complex application with tons of services and running that as a service, as a cloud service to your customers. So a quick word about myself. I'm Arthur Berezin, the founder and CEO of a company called JovianX. We have a cool product that basically helps software companies build SaaS and build cloud services. We've got quite a few customers who have gained some experience and traction and understanding on what it takes to build a cloud product. And this session is basically some of the lessons learned we gained throughout the past few years. So to speak very quickly about what we do in Jovian. So basically JovianX is a platform that helps software companies build SaaS and build cloud services. We focus on three main areas, basically helping software companies with existing software turn their software components or software into cloud and SaaS products by leveraging Kubernetes and offering them specific Kubernetes management tooling, tightly coupled with subscription management, and also allowing their customers or offering their customers self-service portal to do all the operations needed and expected in the SaaS scenario. So basically, once you have a software product, Jovian helps you streamline this whole process of building a cloud product and turning that into a full-blown SaaS product. So basically, let's take as an example a screen that you see quite often. You see a nice login screen of a Hello World application, and you can sign in into this nice little application, or sign up into this nice little service. Quite commonly, you have here like the login, password, etc. So in terms of what this service is all about, is basically a simple Hello World example where you have a few components implementing and realizing some business logic, right? So think of a B2B application. Basically, you have some sort of business logic that implements the core IP, the core thing that the product does, like, right? For example, like an analytics company does a lot of number crunching on data. So you have a database, you have the application component, and then you have some nice UI that shows nice pictures, titles, graphs, monitoring dashboards, reports, and whatever other stuff that B2B applications usually do. And again, I can share these slides later on so you can view this example. So let's see what it takes to build this nice little simple application that doesn't have basically any notion of multi-tenancy, cloud awareness, integration with billing and whatnot. And let's see what it takes to take this simple source code and turn this into this nice little SaaS application that you can register to. So let's sign up for the service. John at helloworld.com, and you have name here, John Doe, company hello, and then you put on the password. So I sign up to the service, and basically once I've signed up to the service, obviously I would like to be able to manage my accounts. I would like to choose and pick various settings. In some cases, it makes a lot of sense to be able to pick the cloud provider, or for example, to pick my geography. For example, if I have to be GDPR compliant, I would very much like to control where my data sits, right? So basically I can choose the setting, choose the region, and in the background, I have my nice little application starting. So what did we see here? And I'm going to jump back to this slide in a few moments. So what have we seen here? So basically, as I mentioned, every SaaS application has a few pillars that make it an actual SaaS application, right? So so basically every application, every product has its own business core or business logic that implements and realizes what the core functionality of that product. So think of that as the bunch of Java code, Python code on the implementation behind a certain product or service that you would like to offer. In order to turn that into a full-blown SaaS product, you have to add three main pillars around that for allowing your customers to be able to use your product, and also for you to be able to serve and manage the service level that you would like for your customers. So again, let's go back to the example. Let's take this simple application that we've seen before, where you have a Node.js application, a MongoDB database, and a nice UI. Let's turn that into a SaaS product. So here we have the source code for the JavaScript Node.js component, and basically we would like to add a subscription management element to that. We would like our customers to be able to sign up, as we've seen through the previous screen. And also we would like to manage the various service level components to that. So what does these components actually mean? So in terms of subscription management, basically I would like to be able to have the notion of accounts. These accounts usually have users, and I need to implement the authentication for these users. Also, I have the notion of feature flags that I would like to turn on and turn off. I have the notion of billing, right? Because as I'm selling subscriptions to my customers, and I can manage plans and have integration with external components such as CRM. The self-serve element usually realizes the ability for your users to be able to register and sign up to the service, but also sign in and make payments, right? And then I have the notion of notifications, etc., to the product. And the third element is the service level, is the service management element, or the service level pillar of your SaaS product that allows you to manage the service level objectives you define, basically allow you to monitor, do alerts, logs, and patches to your product. So why is Kubernetes a really good platform to realize all of that? So Kubernetes is really a good solution to, if you look at the application business core, at the business logic of your application. So again, your SaaS usually consists of few components, and when put together, they allow you to serve and to implement the application itself. So you have like three main pillars around that. So firstly, you can integrate with external services, right? For example, you have an external CRM, you would like to use some AWS service. And a critical part to your SaaS application is the ability to execute and run the business logic of your application. Like think of all the moving parts and pieces of the application that make it what it is, right? For example, if you are a monitoring company, you would like to be able to collect metrics and to be able to do number crunching on them to do what you do. And the third element is the ability to store and serve data as part of your solution. So let's focus on the second and the third elements for executing and running your custom business logic and storing the data. And the real question here is, where do I run this business logic, or how do I implement that? So if we look at the various options that we have for that, for running my custom business logic and data, basically I can either use VMs or cloud instances, but then I have to manage the whole software by myself. I can run it as containers, and then I have to manage the containers, or I can run it in functions or serverless, where I care only about the code. So a few things I need to take into account when I plan my environment and when I plan my project. So I have to take into consideration the costs that it would take me to scale and to bring more customers. I need to take into account my focus, right? Because again, usually teams are constrained. Usually you don't have 200 engineers working on a certain solution, and usually you would like to be able to focus on certain things that are painful and let control and use products and services externally in order to realize various components of your project, and basically give away control to gain focus on things that are important to you, right? So the question is, what am I comfortable delegating to external components? So if I'm running my business logic as VMs, basically I'm responsible for starting the application, running the application, making sure of the application's health, etc. If I'm using containers, so I still own the architecture and the inner components and like the actual runtime of my business logic, right? So I can choose my specific version of my JBoss, for example, or specific version of WebSphere if I'm using a Java application or Python version, for example. And when I run when I would like to use my, for example, when I would like to use serverless to implement my application, again, I don't care about anything other than my code. And basically, I'm giving away all the control to the underlying framework that realizes my solution. So always keep in mind that software is complex and you have multiple components. And each component has to somehow run and to be managed. So when you like choose the various implementation details of your solution, whether you're running VMs, containers, functions, you know, always think of this architecture. You're always going to end up in a complex multi-component architecture, and you're going to need the ability to control the architecture and choose the various settings that choose the various underlying technologies for each component. So next, let's focus on the data layer of my application, right? So I can either store my data in my own databases or in my own underlying data providers. For example, I can use my own storage, my own MongoDB that I manage by myself, or I can use external cloud services. And again, here also the question is, what am I comfortable? Like the real question I should be asking myself when I'm making a choice is what am I feeling comfortable on delegating, right? So if I would like to have full control over the deployment, the maintenance, the upgrades, the backups, periodic checkups, etc. So obviously I would feel much more comfortable having my own database. But hey, if I don't really care about the implementation of the backup, rather I would like to be able to automate that and just run a small script that calls an API, and I'm fine with you know, paying an external service to do that part. So I would probably prefer the cloud managed database or data service, and that solution might be better for me. So again, like, how do I choose what am I giving control of? Basically depends on costs, on my focus on the thing that I would like to focus on, and on the thing that I would need to have to control of. So if I'm fine handing away control to an external service that helps me focus on the things that are important to me, it's usually better to give away control and consume an external cloud service for that. So why Kubernetes? So if you look at, you know, at running the workloads and running and choosing choosing a platform to run my workloads and to run my business logic, why is Kubernetes suitable, and why do I personally think that's a really good choice, considering everything else we have out there, including, you know, all the various new shiny serverless platforms. So firstly, Kubernetes is you know, becoming a standard way and a standard API to manage software. So, you know, if think of all the challenges you need to solve when you deliver and maintain and run software, and basically you would like to have the ability, you would like to have the control, the fine-grained control over the setup architecture layout, because again, this is the reality. You would like to be able to build the architecture that makes sense for you, but you don't really want to implement the specific details that make sure that your database is still alive, right? You wouldn't like to implement the specific mechanism that pushes a new version, for example, right? So Kubernetes is sort of becoming this standard API to manage any kind of software. And it's really easy for you, or not really easy, but it's quite not that complex anymore to take your existing software, your own software, and turn and add this layer of a standard API to manage it. And the cool part is that you have a rich set of tools, an ecosystem of tools that allow you to manage and build your product around these standard APIs. So Kubernetes basically allows you to makes sure that your business logic is running, right? So it executes, deploys it, and makes sure it's running. It's really great for both stateless and stateful applications. Back in the early days, like a couple of years ago, there was this notion that Kubernetes was built specifically for like web applications, and it's not really good for databases or stateful applications. I think these times has passed a long time ago, and I think that the maturity of all the stateful related features is quite so all these features are quite advanced at this point already. So also it's a really good platform to streamline your continuous delivery and continuous deployment of your product. So like there are tons of toolings that are that streamlines this whole process, basically allowing you to avoid this whole pain of writing your own custom Jenkins scripts that we used to do back in the day. So right now you have like tons of tools that allow you to like streamline this process without much effort. Also, there are tons of pre-baked sort of gifts that allow you to manage your software. So you have like auto scaling is a really good example where you have like an ability to really easily scale out and scale in the various components of your software. So for example, like think of all these components here. Based on their own internal load, you would like to be able to scale them up, scale them out, and scale them in, right? For example, you have like for a very specific component does some processing from Kafka, for example, and you have like a huge spike of traffic right now. You would like this specific component to be able to scale out, and once the load is taken away, is gone, you would like to scale it that specific part in. So Kubernetes allows you all these built-in mechanisms to do these really rather complex operations, and it does it for you in many cases. So also like health checks is an important issue. So instead of building and realizing your own mechanism to trigger your application once every minute to make sure it's live, or to trigger every component of your application to make sure it's alive, Kubernetes has built-in mechanisms to do health checks that are actually quite robust. So it allows you to do like internal HTTP checks, or even allows you to write your own custom logic to do the health checks either per component, per service, or per full service for that. And also like from monitoring a log collection perspective, I think there are quite a few standard stacks that allow you very easily to monitor and collect logs of a distributed system. So like logging specifically, for distributed and complex system has been really hard. And Kubernetes, I think, solved that problem quite nicely. And again, like there are standard, very simple to use, very simple to deploy mechanisms and tools to do that. So you have Elasticsearch and Fluentd to collect logs. You have Grafana and Prometheus to do monitoring. Again, very simple to add dashboards, very simple to or relatively simple to add your own custom stuff on top of the standard things that are out there in the community that works quite well out of the box. So let's segue into another quite diverse topic of multi-tenancy. and what does it mean to run and manage a multi-tenant application in the context of SaaS and a cloud product. So when you think of multi-tenancy, obviously multi-tenancy basically means that you have multiple accounts, and there are a few things you need to make sure and think of when realizing or when implementing the business logic around these accounts that usually have the notion of users. Within those accounts, usually you have the notion of an organization above these accounts. So a few things you need to think of when implementing and writing code or building an architecture for multi-tenancy. The first is tenant separation, right? How do you separate various data points or various components and sensitive data to the customer between different customers? Again, usually you end up with a lot of components. Each component processes, handles, stores data, either for multiple accounts or for a single account. And how do you segregate them? So like the separation of data is important. The isolation is also an important part here, right? So like if a user logs in, if a user for company A logs into your product, obviously that's a major no-no for him to be able to see data from another user. There's this notion of density that I'm going to discuss in a bit, and density actually quite correlates to costs. So you either choose dense solutions that cost less, or you care more about isolation, so you get less density, you use more infrastructure, and hence your costs are usually higher. And also there's the notion of compliance, compliance to various security standards that you need to meet. For example, PCI or GDPR. For example, some user data cannot be stored in US, right? Now you have the California rules, also the Californian version of the GDPR that basically also introduces tons of constraints on the user data. And again, your solution is complex. It has multiple components, multiple moving pieces. You need to take and think of every component. So in terms of multi-tenancy, again, it's like you have the various components of your solution, and tenants basically realize, or basically you need to realize the notion of tenants across the different components for your solution to build multi-tenancy, right? So like the very classical, when I talk to people about multi-tenancy, usually the response is, hey, yeah, I need to develop this nice little another nice little row in my database saying user Bob correlates to an account A, user Alice correlates to an account B, and I have like two tenants, Bob and Alice. Cool, I have a multi-tenant application. So reality is not that simple in most cases, as I mentioned before, and this implementing this model would mean, in an enterprise B2B application, would mean that each and every component, each and every black box here in this architecture has to implement code that is multi-tenant, and each and every component needs to also make sure and needs to be able to handle the multiple accounts. So it's quite complex and hard to do that. And if you're like starting from a single tenant application, building this multi-row model, the application level multi-tenancy model is quite hard. So it's usually not always recommended. And again, in the B2B world, it's sometimes even impossible to do that in a timely manner. So again, in this model, you have high density, maybe you have low costs, but also you have a low isolation between tenants, since the processing of these two users is done by the same business logic. And again, like usually you have tons of bugs there, or it's super hard to implement. And this is why it's usually the case where you see in the B2C kind of applications, the business to consumer kind of applications like LinkedIn, Facebook, where you have like millions of users. So you cannot really do anything else other than this model. But in the, again, B2B world, in the enterprise kind of world, like there are multiple ways to achieve the same level or to achieve even better level of isolation by implementing a multi-instance, multi-tenancy. And what that model means is that basically you have a separate instance of your application per tenant or per customer. So in the traditional world, that would mean setting up VMs per customer. But again, today, you know, we are obviously using Docker, we're using Kubernetes, and we're using containerization to run our various software components, and isolating them in the container world, in the container context, is much obviously much simpler, but also it's not that costly right now, because again, you can run multiple instances of databases in a single VM and easily manage them using Docker and Kubernetes. So again, this whole approach of multi-instance, multi-tenancy, obviously you have like the best level of isolation between tenants, but also like the density there is not ideal, right? So let's see what kind of models we can use here to improve the level of isolation for our application. So another model that we can add to our solution is the database multi-schema multi-tenancy. And what that means is that you have like a single database serving all your customers, but you have a database schema per tenant or per customer, allowing you to do this separation and allowing you not to run a separate database instance per customer. So you're not that inefficient in costs, but you also have a relatively good level of isolation between your customers. So another method or way you can use to improve the density of your solution is to implement shared components and basically to build this hybrid model between multi-instance multi-tenancy and have shared components per customer. So like very classical use cases would be to have a separate instance per customer, and then like have, for example, a dedicated analytics service for all customers data that would do the number crunching and basically share some insights on the aggregate of data for the customers. So this basically allows you to like further improve on the density, but still have a relatively good B2B level of isolation between your tenants. So again, and also like multi-tenancy is it's usually, it's not something that you have to do from start to the end. It's a journey, right? So basically you can start implementing your cloud product, your SaaS product, using the multi-instance multi-tenancy model, for example, which is relatively easy to do, right? So you simply like spin up a separate instance of your application, a separate containerized instance of your application. No code changes required, like good level of isolation between the tenants. And then you can add the various shared components for getting a better density for your solution. So you can like take a specific component. Let's go back to our nice little example. We can take a specific component, or we can take Kafka, for example, and say, hey, this Kafka component is serving all the customers right now. Awesome. Let's have that part shared in order to get a better level of isolation. And it's a journey, right? So you can improve component to component basis. And what this means is that you can actually launch right now without reinventing the whole wheel of your product, without rebuilding your whole product from scratch, rather just to do that on a component basis, until you reach the level of isolation and the level of density that works out for your solution, right? So again, like think of cybersecurity solutions. Usually they're very paranoid. They would like to stay somewhere in this realm where you have like the most isolation between the various tenants, but more like lightweight solutions, the more like analytics, number crunching solutions would like to have a better level of density, and they can improve on that in an iterative process and in a step-by-step process. So, what are the few lessons learned that we gained through our journey in this experience in our experience of building multi-tenant SaaS products using these approaches? So first of all, in terms of Kubernetes, namespaces are really good mechanism for separating tenants, right? So you can deploy, if we're talking about the multi-instance, multi-tenancy model, you can deploy a specific instance of your application per tenant and have your cluster run your affinity or anti-affinity rules in order to be able to, to manage them smartly on the cloud instances in your Kubernetes cluster. But always never forget that namespaces are good for separation, but they do not really isolate data between the various components, and you need to do that yourself on top of that. So you can use various common mechanisms to do that. So you can use Kubernetes network policies to separate network traffic between the various tenants. And I have here a nice little example that I'll be able to share later on. Also, container sandboxing is also an important piece. It's relatively early days for sandboxing. So what sandboxing means is that it implements this layer around your container, around specific kernel level system calls around your container, basically preventing the workload getting out of the container into the host node, and basically allowing you this level of separation between, allowing a VM level of separation between the container and the host workload. So this is a relatively early days for this feature. Some cloud providers also already provided this production, but these are like new features. Other cloud providers still don't have that option. But obviously with time, we're going to see more and more cloud providers offering that as a probably even a default option, although it does have some impact on performance. So like usually there are like a few percent of impact on performance depending on the application. So you can check out gvisor. It's an open source project for container sandboxing. I think it's a default or a feature supported in GCP as part of their managed container service product. Another lesson to learn for us is that Helm is a really good mechanism to deliver releases per customer, per namespace, and that actually allows us to scale very easily. So like think of a new customer coming and joining your solution, and basically getting this nice little GUI signing up to your product. Once a customer is signed up, you do a simple Helm deploy per customer, and then basically you have an instance of your application running for that customer, allowing you to manage a specific version per customer. Right? So this is basically a Helm. Helm is a very good underlying mechanism to deliver, to actually provision and create an account and create a tenant for your software on a separate namespace. But it's also a very great tool to deliver upgrades per customer and a customer-to-customer basis, right? Which basically means that you can update some of your customers when you have a new version, but not all of them, right? For example, you have like the more, like the larger companies, the larger customers that are very sensitive about upgrades, right? So you can deliver those specifically, updates to those customers specifically based on the maintenance time that they define, right? So usually like you have this notion of a maintenance window that you would like to offer to your customers, specifically to the enterprise, like the larger companies. Usually like they're really like opinionated about when should a software upgrade and when a new feature should be delivered to a product they buy from you, right? So you can basically version that and use Helm as an underlying mechanism to implement that part. Right. So another, like, Helm is really good also from a perspective of a multi-component software delivery, right? So usually, like, again, going back to this nice little diagram that I love so much, there are multiple moving pieces, multiple moving parts in this software. I would like to be able, obviously I can like have multiple YAML objects to realize each and every component. I have like deployment, stateful sets, replica sets, whatever, realizing this whole component, but I would really like to be able to deliver a customer, right? Or create this notion of a customer that has multiple moving pieces to implement the application for that customer. So Helm is a really good way to deliver and upgrade a specific version of a software and not needing to take care of this whole thing by myself. And I can also like do cool stuff like such as reverting a customer to a previous version when weird things happen, etc., etc. So like Helm does provide that level of management that we found very useful in various use cases. So another note on costs and on focus. So like usually when we talk to like customers and users and, you know, just folks who are building a cloud product. So, you know, when you talk to smart engineers and you get a bunch of smart engineers in a room, usually like you have, you know, this whole phenomenon of you know, iterating and building and adding more and more ideas. But, you know, time and being able to release a product very quickly is very important, right? You need to be able to learn and iterate based on things that you learn. So focus, I think, is the key here, and like focus on delivery is also very important. So so again, like don't think of like building a system for 10,000 users before you're actually sure and know you're going to have 10,000 users. Or even better, like start with a few, start with 10 customers, start of building a system for 10 customers and iterate based on the things that you learn from your experience, because that will allow you to better understand which components are important for you to focus on and which things are, you know, working out of the box. We've been, you know, in many use cases where, you know, we've gotten like, we've bashed around our heads around specific components that were super hard to scale, super hard to implement multi-tenancy around them, but then realized, hey, you know, it doesn't really matter. You know, that component is you know, we don't need to focus on. We can just, you know, have more copies of that and or just, you know, have a single instance of that and not care about scale at all, because again, that component, for example, like scales quite well internally. And like I would like to end like the content for today again, and there are like a lot of topics I can add, and, you know, building SaaS is super complex. I haven't talked about like so many topics about integrations and using various billing systems, integrated with your CRM, integrated with your internal workflows. Like there are tons of things we can discuss here, but one thing that you know always struck me as true, and that will probably never change, is that change is the only constant, and the only constant is change. So things are always going to change, and the key thing here is to release something, learn from the experience of it, and then iterate. And then like this closed loop cycle is a fundamental part to actually building good solutions and improving them over time, instead of wasting a lot of time planning and then realizing that what we've built even not that important. We've solved a problem that hasn't been an actual problem. So on that bombshell, I would like to end my session today, and thank you all for staying with us. I would like to add another small note that I kind of skipped in the beginning. We are working on a new product that helps around Kubernetes application management in a multi-cluster, multi-cloud provider, multi-managed Kubernetes environment. And if you are interested in joining our closed beta, feel free to reach out. We are bashing our heads around this specific area. So feel free to reach out and be happy to chat with you if you are working with multiple Kubernetes providers or multiple managed Kubernetes services and products of the cloud providers. So that's it for today. And again, reach out if you would like to get a copy of the slides. Happy to share them. And that's pretty much it for today. So thank you for joining, guys, and have a nice rest of the day. Yeah, so I think we forgot about questions. So do we have questions? Elizabeth or Alex, can you facilitate like the few questions that we've been collecting throughout the session? Yeah, so Sanil asked me what's my email. So my email address is arthur@JovianX. Yes, there you go. Quite straightforward, but also like feel free to reach out through any contact to this session. I'll be happy to share that with you. Any more questions that we have from the audience today? Right, so is it possible to migrate an existing Kubernetes deployment to JovianX? So yes, thank you, Alex, for asking. So yes, you can obviously manage your cloud solution and SaaS product via JovianX by migrating. So like the way it works is that we have this nice little notion of an application blueprint that is part of our product, and that basically wraps your Helm application. Basically, the blueprint is a wrapper for your Helm Kubernetes application that allows you to facilitate and manage your customers through JovianX, basically allowing you to have this notion of accounts, tenants, and also manage the various components for your application. Okay, so we have another question here from Sanil. So what kind of customers are using the platform? So normally we see the enterprise kind of B2B use cases for for databases as a service products that we're building, analytics as a service products that we're building, or cyber cloud products. For example, like think of any complex application would be a good use case for us. Like this architecture is something I see on, or similar to this architecture is something that I see on a quite day-to-day basis. And these are like sort of the applications that we usually deal, like the enterprise, like the mid-market or enterprise B2B applications. Right, so we have another question here from Barak on serverless and multi-tenant applications. Any insights? Yeah, so that's a good one. So I think that all the principles that I've discussed here on multi-tenancy are applicable in the serverless world as well. right? So you always need to take care of separating user data. You need to take care of segregating between the various tenants within your application. The question is, how do you do that? So with serverless, the thing is that the multi-instance approach becomes much more complex because of, I think, like, and this is like, I think that another area that the serverless world is probably going to improve on time. And that is the lack of good management tools for deploying serverless applications. And I think that's going to improve on time. And like, my assumption is that serverless is going to get there, but still, like, you know, the thing is that you're giving away control. And the question is, like, what level of control should you or do you want to give away? Right. So another question from Jeffrey. So is JovianX platform a multi-cloud solution? So yes, JovianX is basically fundamentally implements multi-cloud, where we don't care much about the cloud provider. Rather, we work, or our platform works with the Kubernetes APIs directly. That can be deployed on multiple clouds. So in this example that I've showed before, actually that's been implemented by, let's see, what do we have in the example here? This is our staging environment. So here we have 1, 2, and 3 clusters realizing this implementation. All 3 of them, I think 3 separate clusters on GKE. But again, you can add your own custom Kubernetes clusters and run your workload on any cloud provider. We've tested it with Azure. We've tested it with AWS EKS. We also have a customer, or actually a few customers, running on Kubernetes with Windows containers. So that's also something that we see that quite interesting. Turning Windows-based applications and .NET-based applications that cannot be ported into .NET Core product being turned into as full-blown SaaS applications on Kubernetes. So super exciting and interesting for us. Obviously, tons of cool things to play around these days. All right, so it seems like that we are past due time, and if you have any further questions, feel free to reach out. And again, thank you all for joining us today. I've had the pleasure of having this session, and thank you, and have a good rest of the day. Take care, bye-bye.